Hi, my name is Gita J. Kumar, and my science fair experiment is testing whether or not artificial heart valves will work and function as well as real ones. My experiment is in the category of biological sciences, and I chose this topic because I have a vast interest in medical sciences and things like that. And I find the human body very interesting. Now, in the human heart, there are 4 different types of valves: the tricuspid, the mitral, the aortic, and the pulmonary valves. The mitral and tricuspid valves allow blood from the atria into the blood ventricles, while the aortic and pulmonary valves escort the blood out of the blood ventricles. The main purpose of a heart valve is to prevent the backward flow of blood, so blood that has already been in the heart does not come back into the heart. Now, there are 2 main types of artificial heart valves: tissue and mechanical valves. Tissue valves are not really artificial heart valves because they are taken from the cells of cow and pig valves, and they are grown in a separate laboratory, and they are then placed into the human body. There are many risks to this because it can cause autoimmune diseases. The immune system could identify an foreign invader and attack the body itself, potentially causing death. And tissue valves last for about 10 to 20 years, so they do have to be replaced. Mechanical valves, on the other hand, are designed so that they last forever, and they have different designs like the ball and cage, and it really just depends on which valve you're trying to replace. Another risk of this is patients who generally get the first surgery, they have to be on a blood thinner for the first few months. A 3D valve would not be considered either of these, and potentially could save many lives and have less risk. Now, this experiment is beneficial because 610,000 people die every year because of cardio diseases. And out of that, 25% of deaths in men and women are caused by cardiac diseases. 5.96% of people suffer from cardiac valvular disease alone. And 3D printing heart valves is easier, more efficient, and faster, and can potentially save hundreds of thousands of lives in the future. Now, to conduct this experiment, I first took 33 human participants and took the pulse of them by using my thumb and placing it on the main vein of their wrist and measuring for 15 seconds and multiplying that number by 4 to get how many pulses they give off per minute. And to conduct the experiment, I figured using water would not be realistic enough, so I made a little mixture of fake blood which had cornstarch, water, and food coloring. The cornstarch was added because blood is generally a bit thicker than water, so we needed to be a more real consistency, so that's why cornstarch was added. To make the valve, I used a 3D printing program called SketchUp, which is a very simple and effective program, and the design of my heart valve was cylindrical. So I printed out 7 heart valves, all using different materials. To attach the heart valve into the actual thing itself, I used a box and cut 1.5-inch diameter circles on each side, and inserted a clear bendable pipe in both holes, and left a small space in the middle. In the space in the middle, the heart valve was then taken and attached into the clear bendable pipes, and the diameter of the heart valve was about 0.25 inches smaller so that it could fit more tightly into the bendable pipes, and the valve was then attached with zip ties. The water was then sent through to see if it created a pulse or not. Now, the results of the experiment are a little bit complicated. It could be argued either way that the experiment worked or didn't work. Now, I said that my hypothesis did turn out to be correct, although the data that was retrieved from the experiment did not completely support it. If you look here, the mean of the human participants was 75.4, and that was the real heartbeat. But if you look at the most bendable material, number 7, the average for that was only 8.6. And although material 7 did have the highest amount of pulses, it was completely far off from the real results taken from humans. Now, you can see here in figure 2, trends in data show material 1, 2, and 3 all have 0 for all their data because they were very hard, non-bendable, and very hard to create a pulse through. Material 7 had the most amount of pulses because it was more soft and bendable and more pliable. Now, if you look at the variance of material 6 and 7, the averages are very close, but the variance is almost 4.6 off. The variance is huge, but the means are very close. Now, the data supported my null hypothesis better than it did support my alternative hypothesis. My null hypothesis stated if a silicone-like material is used, then the pulse would not be relative to a real heartbeat. My real hypothesis stated if a silicon material was used, then the 3D heartbeat would be more closely to a real heart valve. Now, in conclusion, aforementioned, the experiment did not go exactly as planned. The data retrieved was not as expected, but you could argue that the hypothesis was correct. Now, when other people did the experiment, they did use a more ball and cage valve, and they used metals, not 3D printing material or plastic. And there are many reasons why it didn't work. And you could say that I didn't actually have a real control that was a part of the valve experiment itself. My control I considered to be my human participants because they were the ones which I was using the heartbeat from. But it could be argued otherwise that I didn't actually have an official control. And the design of the heart valve was not was not the same as a real heart valve because it was more cylindrical, and real heart valves have more of a circular slit in the middle, and this is more of a cylindrical type of thing. Next time when conducting this experiment in the future, it'll be taken into hand that a more real heart, more effective design will be used when making these, and the number of trials will match the number of human participants which were used in the experiment. Questions?
Okay, so how exactly do you measure how artificial heart valves work as opposed to real ones?
So the real heart valves, basically I measured the pulse.
The pulse?
The pulse of the human participants, and then the artificial was for the 3D printed ones.
Yeah.